mathematics exam. I'm going to try to show how some online videos of these problems could be really useful to students interested in math. So here's the first problem. We're supposed to compute 1 trillion minus 777 billion, 770,777,777. Now I want to show a couple of different ways to do this, but the first way I want to show is just how to approach a problem when you have a lot of complexity like this. And what I want to do is just say, let's take a simpler problem. 10 minus 7. Well, we know that's just 3. Okay? So now let's do 100 minus 77. And we're going to start looking and see if we see any patterns. 100 minus 77, well, 100 minus 70 is 30, and then 0 minus 7 is minus 7, so we get 23. 30 minus 7 is 23. 1,000 minus 777, by very similar arguments, 1,000 minus 700 is 300, and then we have to subtract 70, so we get 230, then we have to subtract 7, so we get 223. Actually starting to see an interesting pattern. Seems like we always have a 3, looks like it's at the end, and we're starting to develop some 2s. Let's just see if we can do 10,000 minus 7,777. Well, 10,000 minus 7,000 is 3,000. Minus 700 is 2,300. Minus 70 is 2,230. Minus 7, we get 2,223. So it looks like we're starting to have all 2's and then ending in a 3. So we might guess, since we do have a number like this, all 2's and ends in a 3, that that's the answer. And how could we see that? Well, we have to ask ourselves, what number do we need to add to 777,777,777 to get 1 trillion? Well, what happens if I add all 2's? Well, if I add all 2's, I get all 9's. So I'm just 1 short, so I have to add all 2's and then a 1, and that gets me this number. Okay, so that's one way of looking at it, where you break it down into a simpler problem and look and see if you can see a pattern. In that case, the number that you would guess from the pattern happens to be here, and then you can check, in fact, that when you add this number to this number, you get the right answer. Now, I wanted to show one other way of looking at it that's a little bit more advanced and involves knowing a little something about decimals. We know that 1/9 is 0.1111111 repeating forever. And we know that 9/9, which is 0.99999 repeating forever, is actually equal to 1. So how is that going to help us on this? Well, we have a number that has a 1 followed by a bunch of zeros, which I'm going to think of in my analogy here as 1.00000. And I have a bunch of 7's, which by analogy here I'm going to think of as being 7/9, which is 0.7777 ... Now what do I have to add to 7/9 to get to 1? Well, we know we have to add 2/9, so 7/9 plus 2/9 equals 1, and 2/9 equals 0.2222 repeating. So that leads us to speculate that the answer is going to look a lot like A. Well, the only problem is these repeat forever, whereas these actually stop. And we notice again that if we check A and add all 2's to all 7's, we get all 9's, just like we got here. The difference is these 9's go on forever. And because of that, this is equal to 1. In fact, you can see a couple of videos about this on the internet, and I'm sure your teachers could explain that to you as well. But when it stops after how many 9's? 12 9's? What we get is 12, sorry, when we add 12 2s to 12 7s, we get 12 9s, so we have to add one more. So this one leads you to guess that the answer is going to be A, but when you check A, you notice you're actually one short. So you can move on to B. So this is actually an interesting starting problem. A lot of times the first problems on these are pretty easy. This isn't so easy. Wanted to give two kind of fun ways to look at it. One way just shows how to attack a difficult problem, and another way is a little bit more advanced, involving decimals and fractions, just to see a similarity with this problem. So hopefully this was instructive about problem number 1.